Okay, so yeah, yeah. So I guess I am audible. So hello everyone. Again, I'm back with another DP problem. So in today's video, I'm going to discuss this problem C of educational led for the DP problem contest. So this problem is C vacation. So without wasting much time, let's get started with the problem statement. In this problem, what we have given is there is a guy whose name is Taro, and he's going for his summer vacation from which is going to start from tomorrow, and he has to decide and he has decided to make plans for it now. And vacation consists of n days from day 1 to n. Okay, and for each day he needs to choose uh, one out of these three activities, and each one of these activities on different days is will help him to gain some happiness. So if at particular day I he is performing ith activity, basically, let's say, yeah, if at ith day he is doing swimming, so in that case his happiness will be incremented with a of I. If at ith day he's basically catching bugs on mountain, in that case his happiness will be incremented by p of I. Okay, and if he's doing homework at home at that day, his happiness will be incremented by c of I. Okay, so what I have to do is, as Taro also gets bored easily, so he cannot do the same activity for 2 or more days consecutively. And what I have to do is, we have to maximize the total points of happiness that Taro can gain. And the constraint for n is up to 10 to the power 5, and the values can go up to 10 to the power 4. Okay. So what I have to do is, we will be given this input format where for each day, I will be having three different happiness values that I can gain, that Taro can gain if he will perform that particular activity on that day, right? So let's take this input as a sample test. So there are 3 days in his vacation, and on each day, if he performs A, B, or C as his activity, so uh, yeah, he can increment his happiness value with that AI, BI, or CI value. So let's quickly see what can be the possible arrangement for this particular test case. So maximize the total happiness value that Taro can gain. So just by observing, we can say, as Taro can't repeat same activity on 2 consecutive days. Let's say if at day one he is performing activity C, and at day two he is performing activity B, and on day three he is performing activity C again. The total happiness he can gain is 210, which will be the maximum amount he can gain in this particular test case. The so that's how I can try run this test case. So let's analyze this problem generally. Let's say if yeah, there is there are n days in his vacation, and let's say if I am at day and the previous activity which Taro have performed on day minus one is previous. So on this day I can iterate on all these three activities from activity A, B, C. If previous activities A, I can perform these two, like I can perform one out of these two. And if the previous activity is B, I can perform either A or C. If the previous activity is C, I can perform either A or activity B on that day. So that's how I can decide. So for you can see that for each day I need to make choices whether to perform A or C or B based on uh, the previous activity I have performed, right? So let's see if I am formulating this problem using DP. Let's say I am doing a DP state. Uh, so in general, if a problem follows a DP, let's say if in general if problem is a DP problem, the steps I generally follow to solve a DP problem is I first try to form a DP state, then I try to form a transition, and then I try to find base cases and final sub problem. And after all these four steps, I always check what are the time and space complexities of that particular DP solution before writing the code. So let's go to the step. Let's say the DP state is DP of day comma previous, which will be storing the maximum value of happiness Taro can gain from this particular suffix. Let's say this is the particular day. So in this particular section, he can the maximum value of happiness he can gain such that he has already performed this particular previous activity on this day minus one, right? So this is the DP state, and let's see what can be the transition for this kind of a DP state. Okay, so I am having the value of previous activity. Okay, so I have to check if A is possible on that day. If A is not equals to the previous activity, I can perform Ath activity, and if B is also not if previous activity is not B, I can perform B. If previous activity is not C, I can perform C. Let's say if I am performing activity A on that day, the happiness value I'm gaining will be h of day comma 0, because A represent this zeroth activity. I will represent A with 0, zeroth column, B with first column, and C with second column, because I will be storing the happiness value as h of n cross 3. Basically, I will be storing this happiness values in 2D matrix of size n cross 3, where h of I comma j will represent the happiness value I can gain, that Taro can gain on ith day if he will perform the jth activity, right? So that's how I will be storing the happiness values. So let's see the transition. Let's see transition again. If at day he is performing eighth activity, the happiness value he will be gaining is h of day comma 0 plus dp value of day plus 1. And for this particular new state, the previous activity with what he have performed on day will be the zeroth activity. And similarly, if he is performing B activity B on that day, the happiness value he will be gaining is h of day comma 0 day comma 1 plus dp of day plus 1 comma 1. And if he is performing activity C on that day, the happiness value he will be gaining is h of day comma 2 plus dp of day plus 1 comma 2. And what I have to do is I need to take the maximum out of all these possibilities, because I need to maximize the total happiness Taro can gain. So base case, I will uh, handle this while coding, and let's see the final subproblem. As the final subproblem will be something like this: dp of 0, and the previous activity is not fixed, right? So what it is showing? So it will be storing the maximum amount of happiness he can Taro can gain from 0th date up till n minus 1 at day. But if I am currently at 0th day, what will be the previous activity? I can't fix the previous activity, so I have to take the maximum of all these three possibilities. Whether 0 is the previous activity, whether 1 is the previous activity, whether 2 is the previous activity for before the 0th day. Because before 0th day, there is not, we are not having a valid day. So uh, we have to handle all these three possibilities, right? And let's analyze the time and space complexities. As you all know, the formula for time complexity is number of states times 1 plus number of transitions for each state. This is the formula for time complexity, for calculating time complexity of a DP solution. So number of states for this particular DP is day can go from 0 to n minus 1, and previous activity can be 0, 1 or 2. So the total number of states will be n cross 3, right? And the number of transition for each DP state is at most, obviously it will be 2, but let's say it's 3. So yep, 3 though 9 times n, so yeah, 9 times it will be 10 to the power 4 because n is up to 10 to the power 4 or 5. N is 10 to the power 5. So 9 times 10 to the power 5. Yeah, time complexity will be 9 times 10 to the power 5, and the space complexity will be 3n, which will be 3 times 10 to the power 5. Space and time complexities are not going out of bounds, so I can code this solution. Let's quickly go to the coding part of this solution. I have already coded this problem. So initially I am taking n as input, which will be the size of vacation, and I am storing the happiness value in 2D matrix where h of I comma j is representing the happiness Taro can gain on ith day if he performs jth activity on that day, right? So that's how I'm storing the happiness values for all I going from 0 to n minus 1, and for all going from 0 to 2 I'm taking input, and after that I'm yeah, in this particular problem I'm using recursive code for the DP. If you want you can code iterative in iterative manner also, but I feel that memoization is simpler for this problem. That's why I've coded in recursive code. That's why I've coded recursive function. So let's see the base case. Let's say day is equals to n. That means I have already processed all the days from day equals to 0 to day equals to n minus 1, right? So if I have already processed all the days and days is now out of bound, so I basically this particular new day will not add any kind of happiness, so I'm returning 0. And let's go to the transition part now. I have initialized the answer with 0 because the minimum value of happiness that I can get out of this level, out of this day is 0. And now I am iterating to each activity going from 0 to 2. If this activity is equals to previous activity, so that means I can't perform this activity on that day. Otherwise, I can check whether I can, if I can update the answer value while performing this particular activity on that day by maximum answer equals to max of answer comma h of day comma activity plus recursion of day plus 1 comma activity, because this is the happiness value Taro can gain by performing this particular activity at that day, plus this is the new state for this DP, and for this new state this activity will be the previous activity, and I'm returning the DP. I'm storing the value inside DP and returning that, and here I'm checking the memorization condition, and this is the final sub problem. Let's check the test cases. This is the first test case. Let's run the code. uh, it's taking some time. Output is 210. It is correct. Let's check for the second test case now. Okay, 100, it's again correct. Let's check for the third test case. Output should be 46, and it's 46 correct. Let's quickly submit this code now. Let's see whether it gets accepted or not. Accepted. So that's all for this problem C, vacations. Let's quickly summarize the problem. So basically what was given in this problem is, so there is a guy named Taro who is going for a vacation of n days, and for each day he can perform either activity A or B or C, and for each day these activities are having some kind of happiness indexes, and I need to maximize the total amount of happiness point he can gain out of this whole vacation. So for each day, I need to choose whether to perform activity A or B or C. And there is also a constraint mentioned in this problem that Taro can't perform same activity on day minus on I minus one day and ith day, right? If he has performed activity A on the previous day, he can't perform activity A on that day. He can perform only B or C on that day. If B is the previous activity, he can perform A or C on that day. If C is the previous activity, he can perform A or B on that day, right? So this is the problem. So for that problem, I have formulated a DP state as DP of state, day comma previous, which is storing the maximum happiness Taro can gain from this particular for this particular interval, day to uh, last day, such that he has already such that he has picked the previous activity on the day last day, day minus one. Let's see the transition part. Okay, yeah, yeah. DP of day comma previous is if he is performing activity A on that day, the happiness value he can gain is h of day comma 0 plus dp of day plus 1 comma 0, because if he is performing activities 0, or you can say activity A on that day, so for the next day it will become the previous activity, right? So if he is performing activity B on that day, activity B will become previous activity or for the next day. If he is performing activity C for that day, activity C will become previous activity for next day. And I am representing activity A by 0, activity B by 1, and activity C by 2, right? So this is transition. And as final problem, I have to consider both all these activities as a previous activity ones, because for day 0, I can't fix the previous activity as 0 or 1 or 2 for day equals to minus 1, because day equals to minus 1 is not a valid day. So I need to consider all these possibilities, whether to perform activity A or B or C previously. And time complexities and space complexity for this problem is linear, big of n. And this was the code for this problem. I guess you all have understood the problem. That's all for today's problem. Thanks for watching. Bye bye.